Hello everybody. This is a graphical illustration of what is called a Newton method or descent method. Here we look at a simple function, more or less like a parabola. And the procedure is that the software needs some initial point. And here it is denoted x0. The corresponding value at that point of the objective function is denoted y0. So starting from this point, the software moves in the direction of the descent, and it finds first the derivative. If you go up in this direction, you increase the value of the function. If you go down, you decrease the value of the function. So the software goes in this direction using the derivative that it finds. And then thus it obtains the next point, x1, and the corresponding value at that point, y1. Then it does the same starting from this point. It finds the derivative here and goes in the direction of the descent. Finds the next approximation, which is x2, and the corresponding value of the objective function, which is y2. While doing this, the software measures the distance between the values of the objective function. It is shown in red here. And it assumes that it has approached the minimum with a good approximation if this distance between the two successive approximations is small. Our minimum is right here. This is x minimum and the corresponding value, and that point is y minimum. The software will not necessarily obtain exactly this x minimum. It may stop somewhere close to this point, like here, just because the values of the objective function somewhere here will be close to one another. And from this description, we can imagine what problems may arise in general. Look at this function here. Look at its behavior at the left infinity. I'm assuming that this continues to minus infinity. It becomes almost flat, but not exactly flat. So the minimum is attained at minus infinity. But the software, by looking at the values of the objective function, will report that it has attained the minimum somewhere here, not minus infinity. This is another illustration of the problems that can arise. We have a function which has two minimums, more or less here, the right minimum, and another minimum is here, the left minimum, okay? So what happens is that we may have more than one minimum, which may not be a problem in the two-dimensional case that we're looking at here, but in the multi-dimensional case, it's difficult to chart anything, so you will not know how many minimums you know. And besides, you don't know the global one. In this two-dimensional case, after minimization of this function, I can obtain two values, one which is minimized here, another which is minimized here, and then I can compare them, and then can I say that the value at the left minimum is better. But in general, since you don't know even how many minimums you have, you cannot find all those minimums, and obviously you will not know which one is the global. And finally, the solution depends on the initial point. Remember that we started here from the remark that the software needs the initial point to start successive approximations. And here, if I start here from this point, for example, I will end up at the right minimum. If I start at this point, I will end up at the left minimum. This is all about geometry. Thank you.